In this video, we will be having a rundown on an Anki deck on chemistry, grade 11 chemistry. This will be specifically about functional groups. Yeah, just functional groups. And we're also, yeah, that's all I'm gonna say. Okay, let's start. Name this structure. So we can see that there is an oxygen atom in the center, and in a symmetrical sense, we have two carbon atoms in each side, one in the left, one in the right. So how many carbons do we have? 1, 2, 3, 4. How many hydrogens do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I don't think counting the number of atoms would matter. Let's see what the answer is. Okay, so this is diethyl ether. I think this is what it just looks like. So we just have to memorize it from there. It's not dimethyl. Dimethyl is a different story with a different illustration. Okay, what is this compound? So we have NH2 at the end. It has something to do with nitrogen. I'm thinking it's nitroethane. Nope, it's ethylamine. So this compound has an amine. So RCH2NH2. NH2 is located here, typically with a CH2, and I'm not sure what the R stands for, to be honest. It's been more than a year since I've studied this. What is the UPAC name of the following molecule? Okay, I think it's best to start counting from. We need to see which side we start counting from. We'll consider our options because if we start counting at the left, that means bromine is more important. It has a priority compared to CH2, CH3. Looking at the choices, definitely 3-methyl something something. This choice is already wrong. We're just choosing among these three choices. So 2-broma, 3-methyl, meth, eth. Okay, so obviously the leftmost choice is already wrong because we have two carbons here. So one carbon is meth, two carbons would correspond to eth. Here it says meth, so that just basically means we only have one carbon and three hydrogen atoms, which is not the case in this illustration. It's either this, the yellow choice, or uh, this, 2-ethyl bromobutane. I'm thinking it's this yellow choice, 2-bromo 3-ethyl butane. Okay, that's correct. It's correct. Um, so 2-bromo ethyl butane, it has four carbons in the main structure itself, C C C C. Alkyl halide or haloalkane or acid halide present. Bromine is on the second carbon. So according to the solution here, it is clear that we start counting from the left, not from the right. 3-ethyl, that's wrong. So 2-bromo 3-ethyl butane. Warning, this exercise question is rigged. What? Sir Carl needs. So, yeah, this is the name of my teacher. Please explain why I came up with this. Okay, so. And the answer said was to be 2-bromo 3-methyl pentane, when the parent chain visually shows only 4 carbons. Yeah, what I wrote here has a point. If the answer was supposed to be 2-bromo 3-methyl pentane, there should be in the main region itself 5 carbons, not just 4. And the substituent is in the third carbon. Sorry for the language. Substituent in the third carbon. Yeah, it's ethyl, not methyl. I am yet to recall the difference between ethyl and methyl. Okay. Um, which is an amino functional group. Uh, this is challenging. Actually, don't know. What's the answer? Okay. Why though? If only I still have uh the list of functional groups. Do I? Not sure. How many hydrogens are missing from this extended structural formula? So it is apparent that we have 3 carbon atoms and we only have single bonds, just single lines. The story could possibly be changed if, for instance, in the right side we have instead a triple bond or a double bond, because that would reduce the number of hydrogens, depending whether it's a double bond or a triple bond in the first place. But here in our scenario, um, 1 carbon can have a maximum of 4 connections. So what we see right now, for instance, the carbon here at the leftmost side already has a connection to oxygen. So the remaining 3 could be the hydrogen atoms. So we have 3 hydrogens here. No hydrogens to attach in oxygen for some reason. Definitely there's a reason for that, but I just can't identify it now. Carbons here, there are 2 connections, so only 2 hydrogens can be here. So 3 plus 2, that's 5, plus another 3, so that's 8, letter D. Yeah. Next. Uh, so what's the name for this? We have 4 choices. 1, 2, 3, 4, 5, 6. We have 6 carbon atoms in the main region. So, okay. I think I have to admit, I'm not prepared to teach this. Although the reviewer is here, um, I could just do away by showing you the answers and the questions, but it's always better if I'm able to explain them. Um, lucky enough, luckily enough, I was able to make um, functional group videos back in grade 11, so at least there's that. Uh, what's the answer? 446 trifluoro to hexane. Let's see why this is the answer. So 446. Where did these numbers come from? 2. So 2-hexane can also be written as hex 2-ine, as in the 2 is in the middle, it's in between hex and ine. Because here in the second carbon, we see that it is connected with a double bond. Actually, not a double bond, a triple bond. You can see there are 3 dashes. This one is together with the equal sign here, so it constitutes a triple bond. That's why the suffix is "ine," not "in." This is already obviously wrong. So we're supposed to just choose between this, this, and this. Okay, let's identify the other things. CH2, CH2F, trifluoro. I think because we have 3 fluorine atoms in the entire structure, we state it as trifluoro. So this choice would automatically be wrong already. we're choosing between this and this. 446. I still wonder where those numbers come what those numbers mean. But in the main region, we have 1, 2, 3, 4, 5, 6 carbon atoms. I think that explains why 6 is over there. How about the 4 and the other 4? I'm not sure. That's the thing. Uh, I can't assure you that I'd be able to find out the reason as to why we have 4 in the first place. Let's just move on. What functional group is shown? So the clue here is we have NH2, and I guess this is uh, basically a template for any hydrocarbon. Uh, yeah, carboxyl? I don't think so. Halide, amino? Is it amino? Yep, it is amino. So NH2, just remember, is associated with the word amino, RNH2. How many single covalent bonds does benzene C have? Wait, I'm not sure how the question relates to the choices and what we have to look for. So basically, I think we just have to identify the name of the structure. So let's count how many carbons there are in the parent chain or the main region. 1, 2, 3, 4, 5. So we have 5, obviously. Um, so meth S. Uh, what's I forgot the prefix for 3 carbons, but I think 4 is but, as in butane. uh, 5 is pent. So as you can see in all of the choices, we can't exclude anything yet because everything, uh, every choice stated pent. So okay, um, but in the first carbon, we can see the double bond. So there has to be an E and E in the end. As you can see in all of the choices, it was stated. But there's one thing that you have to note. The double bond is attached to the first carbon. So pent 4, you can't say it's in the fourth carbon. You don't start counting from the right. I'm assuming that for letter A, you were counting from the right. So this is 1, 2, 3, 4. So pent 4 in. That's wrong. You count starting. Um, you choose a direction in the sense that in this illustration, the double bond is closer to the left, so we start in the left. If ever this double bond was in the right instead, then you start counting from the right, the number of carbons. So pent 1 in, that may be correct. Pent 2, nope. Uh, Technically, the second carbon, counting from the left, is still attached with the double bond, but whatever is uh, basically, if you count from the left carbon, the carbon located at the left of whatever that bond is, whether it's double or triple, that's the position that you will consider. So pentoene is wrong. If ever you start counting from the right, and let's say the double bond is here, then technically it's still pent 1 because uh, the carbon that you are counting is the first one. Let's say the double bond is located here. Then you count the second carbon. This is when this choice becomes correct. Pentoene. But again, in our scenario, that's not the case. Pentene, mm, it's either B or D. I I don't think there's a difference between the two. But just to be safe, I'll stay with letter B. Yep, it's letter B. Better recognize the position of the carbon that is associated with the double bond. So letter B. Next, name the structure. So we have a triple bond in the middle, and C, and then we have H atoms on each end, on both ends. This is not ethanamine. Ethane, I guess? No, no, no. Even if I'm not sure about the name of this structure, you can see it is recognized that there's a triple bond in the middle. So the suffix is supposed to be "-ine" instead of "a". If ever, I'm not saying that this is correct, but if ever, theoretically, this is just a single dash, that's gonna be considered ethane. If ever you see an equal sign here, so it basically means double bond, it's ethene. Okay? Ethanamine, I'm not sure uh, what illustration may correspond to it. If an alkane has 20 carbon atoms, how many hydrogen atoms will it have? Okay, so this is an alkane. That means no double bonds or triple bonds are present, only single bonds. This would be a lot better. It would be a lot better if we could illustrate it. Um, but definitely, the number of hydrogen atoms cannot be equal to the number of carbon atoms in this scenario. So 20 is wrong. 22, nope, I don't think so. It's either 40 or 42. They're very close numbers. Um, I'm willing to bet that it's so 18 carbon atoms will have two hydrogens each, and for the remaining two carbon atoms on each end, one at the very left and the other at the very right, they'd have three carbons each. I mean, three hydrogen atoms each. So that would amount to 6. 36 plus 6 is 42. 42 is the answer. Okay. Chemical formula of this kind of alkane is C20H42. It has, okay, we don't have to know this. At least in my class, we didn't have to know this anymore. About isomers. How many bonds can carbon form? 4. 4 bonds. The given structure is an example of. This is definitely not skeletal. You should be seeing lines if ever it were a skeletal structure. You can't say that it's an expanded structure either. Where's the expansion in that? Most likely the answer is condensed, which is correct. Okay. Which functional group is represented by the general formula RCHO? So we have CHO, that should be the clue. I think we're dealing with not ketones, maybe carboxylic acids. What's the answer? Aldehydes. Yeah, I made the same mistake as I did before. Um, RCHO is not a carboxylic acid. The correct name for this hydrocarbon is what? So we start counting from the right because this is well, a double bond is closer to the right, so we start counting from the right. We have three carbons, so this is okay. Letter C is the answer. I remember now. So counting from having one carbon to five carbons, we have meth S, prop is three carbons, but is four carbons, pent is five carbons, hex is six carbons, uh, hec heptane, single bond seven carbons, octane, oct, the prefix oct corresponds to eight carbon atoms, 9 is non, and 10 is decane. For 20 carbon atoms, I remember it's icosane, assuming that there are all bonds are single bonds. Okay, one propene. Which of the following is an alkyne? So triple bonds. We're gonna expect that the hydrogen count is going to be low. So definitely not this. 10 is too much. Mm, C4H8. I think this is still too much. C6H6. I think it's C6H6. Just kidding. This cannot exist. C4H6 is an alkyne. I'm thinking this is an alkene. This is an alkane. But this one is too much. Too exaggerated. We don't have that much hydrogen atoms, but not too little. Uh, if you get what I mean. Okay, the following functional group corresponds to, this has to be ester. ROR. Just kidding, it's ether or ether. So ester looks like this, and ether looks like, well, just to help you remember it, just call it ROR, ROR. And ester is a more complicated, has a more complicated figure, R and OR. And there's a double bond, um, so I think that's worth noting. Which of these functional groups is a hydroxyl? OH. NH2 is different. We've explained that earlier. I think that's something else. SH, PO4. PO4 is phosphate. It's different. SH, I'm not sure what that is. Okay, next question. Name the following. 1, 2, 3, 4, 5. Pent. Wait, let me double check. 1, 2, 3. Oh, okay. Um, the parent chain extends not just we don't count this as a parent as part of the parent chain. We count whatever is longer. So we found out that counting from here, 1, 2, 3, 4, 5, 6. The parent chain is longer this way. We don't count wherever the parent chain may be longer. That's where we count. So yeah, this cannot be in a way an auxiliary to the parent chain, because again, uh, if you count the carbon atoms in this position, you'd have more carbon atoms compared to if you count straight. So be careful with that. And of course, we start counting from here because this is where the double bond is. Uh, so let's look at the last word, hexene, 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 hexene. Everyone has hexene. Um, one hexene, one hexene, one hexene. Because in the first carbon, we have the double bond. So that's supposed to say one hexene. Two, dibromo. Okay. So as you can see, we have two bromine atoms. One is at the very uh, last part of the parent chain, and one is in the second carbon. So how many carbons do we have in total in the parent chain? We have 6. One bromine is attached to the second carbon. The other is attached to the last, that is the 6th carbon. So 2,6-dibromo is the correct first part. So automatically this and these two are wrong. It's either the blue or red choice. So for chloro, in the fourth carbon we find chlorine, so for chloro, uh, 1 fluoro, 1 fluoro, and 4 methyl, 4 4 methyl. Yeah, methyl is correct. And it's attached to the fourth carbon. So the red choice is wrong because it says 3 methyl. If that's the case, This CH3 should have been here in the third carbon, attached to the third carbon. This shouldn't have the H2 anymore, if that's the case. So the leftmost choice is the correct answer. Yeah, the blue choice. So yeah, everything that I've stated here is the same as what I just stated a few seconds ago. Okay, what is the name of the molecule shown? Okay, let's start counting. Let's find where the parent chain is the longest. One, two. No, we start here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. No, this is not a parent chain. Where it's longer, it's here. You just count horizontally. Um, so we have a CHO here. Um, Dimethyl hexanal. Hexanol, hexanon. Every choice has hex. Uh, every choice also has 3-ethyl. So in the third carbon, as you can see, we have 2 carbon atoms. So meth eth. 2 carbons corresponds to ethyl. Um, 4, 5 dimethyl. 3, 4, 5. 4, 5 dimethyl. Okay, so it seems to be that the last part is the one that's different. Everything else is the same. Everyone has 3-ethyl 4,5-dimethyl. Hexanoic acid. I think it has something to do with this. We need to remember what this means automatically. I'm actually not sure. Let's see what the answer is. Hexanal. So 4,5-dimethyl, 3-ethyl. So there is an aldehyde on the first carbon. So aldehyde means anal or hexanal. 6 carbons, aldehyde, hexanal. What is the structure? This is, well, just 1 carbon atom, so meth. And there is only single bond, so methane is the answer. Methane, if there is a double bond. Propane, if we have 3 carbon atoms and single bonds. For letter D, um, if the figure had 2 carbon atoms and everything has single bonds. No other kinds of bonds except single bonds. Next, how many carbons do we have here? 1, 2, 3, 4. So this is bute. All choices have that prefix, but only one stands out. We have a triple bond, so A, C, or D are possible answers, but as you can see, the carbon, uh, well, in the left side, counting from the left, in the left side of the triple bond, we have the first carbon atom. So bute 1-ine is the answer. It can't be bute 2-ine. It can't be bute 4-ine. We don't start counting from the right. We start counting from the left because regardless if it's a double bond or a triple bond, we count. We start counting where it's closer. So bute 1-ine, not bute 2-ine. What is the name of the molecule shown? Okay, so we're just given the skeleton, nothing else. But we can survive this. I hope. One, two. Let's see if we could count from the left first. 1, 2, 3, 4, 5, 6, 7. So heptane. There are no double bonds or triple bonds, so methylheptane is the last word. Uh, Wait a minute. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 7. 1, 2, 3, 4, 5, 6, 7. 5-methyl. all, like, except this choice, everyone has two chloro. So I'm thinking we start counting from the right. How do we know that this is wrong? Hmm, let's see. 5 methyl, 5 methyl. 5 methyl is correct. 4, uh, why is the, why do we have the word tert butyl? Not what, I'm not sure what that is. But surely we have in the third carbon an ethyl, so red may be wrong. Just kidding. Uh, 5 methyl. Okay, 4 tert butyl is correct. Everyone has it, so that's correct. I think the best answer is this one. First things first, alphabetical order. So C comes first, then E, then M. Here, T came first. We could just place 2 chloro first, then 3 ethyl, then 4 tert butyl. What is actually the answer? Ah, okay, I'm wrong. 4 tert butyl. Okay, so I got the same mistake as before. I chose this answer. It was supposed to be this. 5 methyl, 3 ethyl, 4 tert butyl, methylheptane. Okay, let's move on. Name the structure shown in the image. We start counting from the right. C 1, 2, 3, 4, 5, 6, 7, 8. This is oct. Oct 1, and we have a triple bond, so ein. Oct 1 ein, letter A. Next. Hmm. I actually don't know this. We don't have hydrocarbons. Uh, Methyl propanoate. I guess you just have to memorize the figure. I mean, you don't really have anything else. You don't really got any other choice. This is ester? No, carbonyl group. What functional group is shown? Uh, OH is alcohol, so carboxyl. Okay, so I was supposed to be wrong. I just guessed the answer, but lucky me. Carboxyl. Yeah, that's carboxyl. No, period. How many hydrogens can carbon bond to? 4. The correct name for this hydrocarbon is, we start counting from the right, 1, and then prop, because we have 3 carbons. 1 propene. Name this alkane, 1, 2, 3, 4. 4 carbons. This is butane. All single bonds, so the suffix would be written as A and E. Ane. Everyone has it, but what makes the distinction is the number of carbon atoms. For ethane, just 2 carbons. Methane, just 1 carbon. Propane, 3 carbons. In our figure, we have 4 carbons. That's butane. Name the following. 1, 2, 3, 4, 5. We start counting from the left because we have this. Coming from the left, this is closer. But at the same time, we have attachments here. This could be two, uh, 2, 3. Let me think. One, two, three, four, five, 6. 1, 2, 3, 4, 5. Okay, I get it now. The parent chain is supposed to be from here, 1, 2, 3, 4, 5, 6, instead of extending here. Because again, we have 6 carbons here. If we continue here, we only have 5. Wherever we have more carbons, that's the parent chain. So this will just be an auxiliary. This is methyl. In the what? 1, 2, 3, 4. In the 4th carbon. So how many methyls do we have? This, by the way, as you can see, we have 3 hydrogens. So this can be written as CH3, such as the ones that we see here. So uh, I believe we have 3 methyls, so that's going to mean, in terms of words, trimethyl. So dimethyl is not correct. Triethyl is. I'll think about this as well as this. Trimethyl, that's correct. So 2, 2, and then in the 4th carbon, we have an attachment of methyl. So 2,2,4 trimethyl hexane. Yeah. There is no ethyl here. One of the choices has ethyl because you might have thought that this was ethyl, but it's not, because that would if ever this was ethyl, then this parent chain should have been longer. But the case is, using this as part of the parent chain, we had the most carbon atoms. So the answer is trimethyl hexane, letter C, 2,2,4 trimethyl hexane. Next, identify what type of hydrocarbon. This is an alkyne, clearly. Triple bond. Okay. Which of the following is an alkane? Nonane. So everyone, letter C and D have double bonds. This one is ine. What's an alkane? Having a single bond. The suffix has A and E in the end, so that's going to be letter A, nonane. Which of these functional groups is an amino? NH2. Knew it. This one, COH, the one with OH, that's going to be carboxyl, I think. NH2 is amino. Okay. Name this compound. So propane, clearly, because we have 3 carbons. Bromine is in the middle. Definitely not just propane. Bromopropane. Not propane. Not propane. Open close parenthesis BR. It's most likely bromopropane. 2 bromopropane. The answer is not in the choices. We're still going to follow the guidelines. We're counting, well, in this scenario, we can count either from the left or from the right. Doesn't really matter. Because the figure is symmetrical. Either distance is equal. So 2 bromopropane. or bromoprop-2ane could also be an answer. Identify what type of hydrocarbon this is. So we have a hydrocarbon here, double bond. So in, it's either A or B. Um, is this an arene, aromatic? I don't think so. Alkene, more likely. Let's try it. Is A the answer? No, it's actually B. Ah, yeah. Um, I got confused with the letters. I was supposed to say B is the answer. Arene is something else. It's a ring of some sort, if I'm not wrong. What is the name of the molecule shown? Okay, we start counting from where? Let's try if it's okay to start from the left. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Mm, definitely not pentanoic acid. We have an oxygen here attached with a double bond. Uh, 2 isopropyl. Okay. I think we're talking about alcohol here. So, pentanol or pentanal? Not sure. But definitely this is 2 isopropyl. 3 methyl. Mm, 1 pentanon. Where is pentanon? I don't think it's there. Pentanoic acid, no. Pentanal. 1 pentanol. I think it's this one, the right most choice. Nope, it's the orange answer. So 2 isopropyl, 3 methyl, pentanal. Pentanal, always remember we have this um, illustration. Like this is supposed to automatically let you know that it's pentanal. We're dealing with the pentanal. Let me just fix this. Okay, so the first carbon has an aldehyde. Aldehyde, so that means pentanal. The one with the suffix anal in the end, or al. 5 carbons and single bond, so that's pentane. 2 isopropyl, not 2 propyl in this scenario. We don't say propyl, we say isopropyl. We have 3 methyl, so 2 isopropyl, 3 methyl, 1 pentanal. Because the pentane is, well, the al or the aldehyde is located here in the first carbon. It's attached to the first carbon. Note that isopropyl is first then. Okay, so how do you know if this is the correct arrangement? You can see that it's 3-methyl 2-isopropyl instead of the one here. Uh, what does the note say? Mm-hmm. Another magical reason. So I had this struggle back then. According to Circle, this region is universally understood as an aldehyde. Okay, so there you go. This is exactly what I was trying to say earlier. Now I'm a lot more sure about what I'm saying. Okay, just get on with it. Um, Isopropyl comes first, then 3-methyl. Important information, additional. Propyl looks something like this. Isopropyl looks something like this. R is the parent chain, I suppose. Okay. So this is just an attachment. This is not the parent chain itself. Let's compare this. So in our scenario, we have isopropyl involved. How does it compare? Sure, we have diagonal lines, but so does propyl. I believe you can analyze that on your own. Next, what functional group is shown? So we just a classic hydrocarbon, single bond. Methyl. This is a methyl. So R is the parent chain, and an attachment is a methyl. If ever there were two carbons here, that would be ethyl. Okay. Carboxyl is associated with carboxylic acid, which is a part of the carbonyl group. So this is carboxylic acid. Carbonyl group has the following general illustration. Hydroxyl group has an OH, so this is what it looks like. A methyl group has R and CH3. Actually, let me picture this. This is useful information. I suggest you take notes. Why is it always taking so much time to summon my camera ever since I updated this iPad? I don't like the latest update, to be honest. The previous iOS has already been doing fine. I'm not sure why they have to keep updating, keep making a newer software version. Well, understandably, because we're trying to be safe from potential malware attacks. I think that's enough reason. But aside from that, I don't know anymore. Next, which is a hydroxyl functional group? NH2, this is amino acid, I think. This is carboxylic acid. This one is hydroxyl. This is the answer. Which is a hydroxyl functional group? This illustration. See? Next. Which is a carboxyl functional group? Definitely not this. Definitely not this. This one in the middle. Yep. This is alcohol that is from the hydroxyl group. That is also under the carboxyl group technically. Okay. Name the following. Okay. I think we've been here before. Let's try redoing this question again. 1, 2, 3, 4, 5, 6. So hexene. 1 hexene. Or hex-1-ene. How many bromines do we have? 2, 6. 2, 6 dibromo. 4 chloro, not 3 chloro. 4 methyl. Okay, this is the answer. Okay. Name the following. Where do we start counting? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. None. In the second carbon, we have a double bond, so 2 nonene. Everyone has it except red. Red is already automatically wrong. 1, 3, let's see. No. 1, 3 is wrong. 1, 2, 3, 4, 5. 1, 5 dibromo. This is correct. The indigo choice. Okay. Bromine present on the first and fifth carbon, and 9 carbons on and double bond on the second carbon. 2-nonene or non-2-ene. And there's a methyl on the 5th carbon. 1, 2, 3, 4, 5. The CH3 over here, that's methyl. Therefore, we have 1,5-dibromo, 5-methyl, 2-nonene. That's the answer. Name the structure shown in the image. So, where do we start counting? From the left, from the right. I think the figure is also symmetrical, so counting from which side wouldn't really matter. But definitely in the 3rd carbon, that's where we meet the double bond. So hex 3-ene. The yellow choice is the correct answer. Hex 3-ene or 3-hexene. 6 carbons in double bond on the 3rd carbon, 3-hexene. Hydrocarbons everywhere else. This is hydroxyl, technically under the carbonyl group. This alkane is a methane. This compound is, okay, we've been here before, 2-bromopropane. This is supposed to be 2-bromopropane, not just bromopropane, because it's in the 2nd carbon. Okay. Which of the following skeletal structure has a formula? Okay, so this time we're given the condensed form and we need to look for its corresponding structure. This is going to be a challenge because we're not going to be drawing anything. This is a laptop. Drawing would be more appropriate if I'd be using an iPad right now, but that's not the case. Okay, let's get on with it. First, 2nd carbon, we have a double bond. Figure 1 doesn't look right. Figure 2, sure. Figure 3, sure. 4, so we're choosing between these two. If we're counting from A to D, B and C are the only possible answers. Let's proceed. How many carbons do we have? 1, 2, 3. What is this? And 4, 5. I think we have 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. I think this is the answer. Letter C. Let's check. Yep. Because if the answer were to be B, looking at this line over here, it's so far for the methyl to be coming from the double bond. The double bond is here. The methyl is supposed to be close to the double bond, and that's only satisfied in figure C. The double bond is closer, well, the methyl is closer to the double bond, so that's the reason why I chose the answer, which is correct. Identify the functional group, amino, just kidding, amine, NH2. What functional groups are shown in the following picture? We have hydroxyl. Well, yeah, I think what's being asked is the red highlight, so that's hydroxyl. Also halide. I didn't know there could be more than one answer. Where do we see the halide? I'm not sure. Anyways, what functional group is shown? This is not amino, this is not carboxyl, this is carbonyl. Carboxyl looks different from this, so definitely carbonyl. Hydroxyl has OH, we don't have OH here. Amino has NH2, carboxyl has, well, again, it's different from this illustration, so carbonyl is the answer, which is correct. Specifically, this is ketone. Ketone belongs to the carbonyl group. I'll be right back in a few seconds. Identify the functional group. Where do we start? Let's identify the parent chain first. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so clearly we have heptene. So letter B is wrong. D is already wrong. It's too short. There's so many there's so many details in this figure. And we can't say that we have 9 carbons. That's too much. So let's say we start here. 1, 2, where do we start? Because there's also a methyl um, here and here. So where do we start from? Either left or from the right? Well, I think because the double bond is closer to the right, we start counting from the right. Even though we have these two guys located in where they are located. So one, in the second carbon we have methyl, 3, 4, 5, 6, 2, 6 dimethyl, and then in the third carbon we have 3 heptene. I think the answer is letter E. 2, 6 dimethyl 3 heptene. That is correct. Why is letter C wrong? It's not 2, 2 dimethyl. You've already disregarded this. For letter B, it just doesn't make sense. We don't have 3 methyl groups. We only have 2. We're only onto dimethyl in this scenario. If you have a carbon chain of 7 carbons, what is its name? Heptano or heptane. Heptano. Where is this? Spanish? I'm not sure. Name the structure. This is... So R, this is the parent chain. R, and then we have a carboxylic acid. Or perhaps this is an aldehyde. I'm willing to bet it's letter C, propanol. Yep. Nice. Because this region is an aldehyde. Identify the functional group. Aldehyde. Yeah. The more specific term is aldehyde. Technically, aldehyde is under the carbonyl functional group. This is carboxylic. Carboxyl. Yeah, carboxylic acid. Identify the type of hydrocarbon. They're all alkenes because their suffixes have E and E. So, alkene. Just kidding. So, as you can see, we have rings. So, it's definitely no longer alkene. So, arene was the best answer, supposedly. I didn't notice the rings in the first place. But whenever you see a ring, something like this, something that looks like a piatos chip, if you're familiar with the snack piatos, we're definitely dealing with aromatics. Okay, next. Name this compound. 1, 2, 3, 4, 5. 5 carbons. So this is pent. A is wrong already. It's either B, C, or D. We start counting from the left. 2 bromo, 3 chloro, pentane. Letter C is the answer. Let's see why B is not correct. 2 bromo, 3 chloro. With respect to alphabetical order, I think C is correct because first things first, what came first was bromine, and what came later was chlorine. So 2, 3. We can say 3, 2, I guess. For bromo, okay, this is a different topic. I think C is the answer. 2-bromo 3-chloropentane. Okay, that is correct. Which of these functional groups is an aldehyde? This one is amino. So the answer is not C. How about COH? This is carbonyl. This may be an aldehyde. How about COOH? I don't think so. CH3, that's a different story. Letter D. Okay. What is the functional group of an ester? ROR? Where's ROR here? No, no, no. ROR is ether. Ester is... which here is ester? I think it's this one. The blue. Yep. Knew it. Oh my gosh. I remember making a joke out of this. So, in order to remember what ester is, the figure should have 2 oxygen atoms. So, the script is, oh Esther, I lost my 2 balls. So oxygen atoms should, well, they look like circles, so 2 balls. As you can see in the other choices, we only have a single oxygen, so they're not answers anymore. They can't be correct answers. Moving on. Identify what type of hydrocarbon this is. Alkyne. We've already had that question earlier. Name the structure. This is propanal. This is an aldehyde. So with the suffix al in the end, yeah, propanal. How many single covalent bonds does benzene molecule have? Okay, so this is, well, C6H6. We've seen this condensed form earlier. We thought it was an alkyne. It wasn't an alkyne. Turns out it's a benzene. It's the condensed form of benzene, specifically. How many single covalent bonds do we have? 1, 2, 3, 4, 5. I think 9. We're just looking for all the single lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 single covalent bonds. Because of this, count the 6 hydrogens and 3 single bonds connecting the carbons. They make up 9. Okay? Makes sense. Which diagram gives the skeletal formula of 2-chloropentantriol? Or 2-chloro-3-pentanol? 2-chloro, right? So 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. C and D are no longer pent. So 1, 2, 3, 4, 5, 6. They already have 6 carbons, so they cannot be the answers. I think the answer is letter A. Letter B is 2-chloro-4-pentanol, or 2... Never mind. Yeah. The answer is A. Okay, I don't want to even think about this anymore. I'll leave that to you. Next. Okay, we've had this already. Okay. We're finished. Thanks for watching. I'll see you in the next video. This has been fun. Although I admit, this has been relatively challenging. it's a good thing that I'm able to remember most of what I'm supposed to know in this lesson. Functional groups are extremely important in organic chemistry. Uh, I hope I survive college. Thanks for watching.